Hello students. So this session is for the beginners, like those who are starting the concept of current electricity, what is series circuit, what is parallel circuit. Initially, lots of confusion you have. So just this session will help you to understand and to keep you in mind that how to solve the issues, like, and how to get the exact details in the circuit when it is in series circuit. So this is a series circuit. Okay, in this series circuit we are having three resistance R1, R2, R3. Okay, and the voltage source, let's say it is V1. I took two voltage source to show you that we can have multiple source in the same line, but for this one, let's say take the net voltage. Let me take one voltage here, right? One source of voltage. Okay, and let us take it V. Let us take it V. Fine. So this voltage source is giving voltage, and three series resistance is there, and the current is I. The current is I. So what happened? There is a word voltage drop. Like for each resistance there will be a voltage drop. Let's say this is V1, this is V2, this is V3. This part is very important to understand what actually happened. The net voltage getting distributed in V1, V2, V3, three voltage drop for three resistance. If I am adding two more resistance, then what is going to happen? That time V will be V is equal to V1 plus V2 plus V3 plus V4 plus V5. So voltage drop will again redistributed. So this part is very important. See, if we are adding multiple resistance, what is getting changed? The current, the main circuit current. This is very important. The current in the circuit, okay? This is called the main current, right? Which is flowing in the circuit like this. Fine. So this current, if you add more resistance, what happen? So your denominator will get increase. That means your current value will be decreased. More resistance you are adding in a series circuit, your main current will be reduced. So this is very important. So most of the cases, in case of 9th students, you are getting questions to calculate the current in a circuit, and you will get a circuit, different resistance, you will get the voltage. You have to calculate the main circuit current first. Then what you are going to do? You have to do like this. So take all the resistance in a series, and the resultant resistance of the series will be, and also in series the resistance are connected, like R1, R2, R3. How does it came? So voltage drop V is equal to V1 plus V2 plus V3, right? So here V is equal to I, main current, R is the equivalent resistance in the circuit, right? So V1 is equal to I R1, V2 is equal to I R2, I R1 plus I R2 plus I R3. Okay, right? From here we are getting, so current is common here, current will be same in the series circuit. So we are getting here our result net equivalent resistance of the series circuit is R1 plus R2 plus R3, right? So this is the formula for a series. Now if you add more resistance, it will go adding R4, R5, n number of resistance you can add in. So current, more resistance you are adding in series means your current of main current will be reduced. This is very important for solving the numerical. Fine. Now next go to, so for series, I think if you forget the things, just remember voltage is getting distributed. So V net voltage V or battery voltage is equal to V1, V2, V3. Current is same. So R series R will be adding. So the equivalent resistance of a series is always greater than the individual resistance. Equivalent resistance of a series is always greater than the any individual resistance. Right? Now let me show you the parallel. In case of parallel, the things are getting changed. Right? So in parallel, what happened? Voltage will be fixed, the current is going to change, distributed, like let's say three resistance, and like this like this. Okay, so this is a voltage source, this is the current. What happen if this is V, this is current I, so current I getting entering here, then current getting distributed. Let's say I1, here I2, here I3. Okay, so the resistance are R1, R2, R3. Again here they will connect, then main current will be always I. Main current will be I. So this is a parallel circuit. So what is the, how to understand what is a parallel circuit? That here the voltage drop will be same. Here it will be V, it will be V here, it will be V. So 2 points will be in the same voltage. These 2 points are the equipotential, like the voltage are same here. Voltage are same here. Voltage difference, not like if this is VA, if this is VB, so potential difference will be same for all the three line. All the three line. So what is distributed? The current. It's like an water line. In a campus, like wherever you're staying, that water getting distributed. So from the main water line, you are getting a distributed pipe, right? Similarly, if current is like water, so that's getting distributed in different directions. Okay. So the theme is that here current I is equal to I1 plus I2 plus I3. This is the key word here. Current is getting distributed I1 plus I2 plus I3. Okay. Now, next is that, so just I just for calculation I remove this part. So current I, V is equal to IR. Then V is equal to I1 R1. Again V is equal to I2 R2. V is equal to I3 R3. Right? So I is equal to I1 plus I2 plus I3 means, so I is equal to V by R. Okay. See, if we replace the part, what we are going to get here, we will get V by R. V by R is equal to V by R1 plus V by R2 plus V by R3. V by R3. So V are common, so we will get 1 by R. So this is equivalent parallel resistance for all these three, 1 by R1 plus 1 by R2 plus 1 by R3. So this is the formula of the parallel resistance. Okay, parallel circuit resistance, and this RP is always less than any single RP less than R1, RP less than, so RP, the resultant or equivalent resistance will be less